We're going to review what we've been going over, which has been the formation of Earth and the geologic time scale. So what originally happened to start the creation of our universe?
The Big Bang.
Yes, the Big Bang explosion. So that is what originally started to create our galaxy and our universe. From there, two elements were created. Which were? Does anybody know?
Yeah, helium and hydrogen.
Helium and
Hydrogen.
hydrogen. Yes, helium and hydrogen. So from there, that is what created our galaxy formation. You also had your supernova explosions. From there, you had a solar nebula. What's the solar nebula?
It's a cloud of it's a cloud of light stuff.
Yes.
It's a cloud of dust
Yes, so it's the rotating cloud of dust and gas. That solar nebula began to contract and flatten out, which created the protosun. From there, you had the accretion to form your planetesimals. To those planetesimals, you had continual impacts and radioactive decay, and our Earth was once covered with what type of oceans?
Molten lava ocean.
Yes, magma oceans. From there, you had chemical differentiation, which led to the formation of Earth's what?
You said what?
From chemical differentiation that led to the Earth's layers, what are the three layers of Earth?
crust, core, and
Yes, the core, the mantle, and the crust. Then we had Mars-sized object that impacted Earth. From there, debris began orbiting Earth, and that created the what? The moon.
I got you, bro. I
Yes.
got you, bro.
So once Earth was formed, then you had that outgassing, which means what gets released?
Oxygen.
Yes, gas that was trapped in the Earth's interior. So once Earth is formed, you begin finding out that Earth is the right planet, the right time, and the right location. And what makes Earth unique compared to the other planets in our solar system?
It's the only planet that can sustain life
Yes, it is the only planet that has life.
in our solar system.
As of now. Also, we are the right size for gravity to hold in oxygen, water vapor, and other volatiles. We also have the lithosphere that's over the weak asthenosphere that gives us our continental crust.
So do other planets not have a magnetic field? We're the only planet with a magnetic field.
Well, okay, but no, if our Earth started out in the same place theirs did, imagine if there was like 4.6 billion years.
What? I don't even
From now,
believe in
or,
that.
yeah.
I just learned.
We don't believe in it? No.
I mean, I think
I
the Earth
don't
could
know.
just people
Right.
more than anybody else, you know?
I mean, people.
Well, again, it all has to do with
They don't
having
got
an
no, they don't got no
atmosphere.
atmosphere. And
Do
they
they,
think it's
but
what?
do they need
Because
we on this planet because we need atmosphere.
He said they need an atmosphere.
They gonna like, you gonna evolve to like your
I see what you're saying.
evolution, yes. Evolution is a real. Alright, so again, Earth is the right location. So if it were 10% closer to the sun, it would be too hot. 10% further away, it would be too cold. Earth's atmosphere in the beginning was mostly water vapor and carbon dioxide. There was no oxygen until microorganisms that could photosynthesize came into existence. And then about 65 million years ago, the planet was struck by an asteroid and killed off most of the species.
It's not proven. It's not proven.
So we had the Great Oxygenation Event, which again, this is when your microorganisms started evolving. This happened about 2.5 billion years ago. And with the increase of these oxygen-generating organisms, it then increased the oxygen that was then being put into the atmosphere. And this is what gave way to aerobic life forms, which are life forms that require what?
aerobic life form?
Yep.
Life form.
What was it?
So aerobic life forms require oxygen,
Oh, so
and it
that's,
also gave way to the ozone layer.
wait, why is it called aerobic if everybody needs oxygen?
Not everybody. You have anaerobic.
Oh yeah, fish and stuff. Oh yeah.
There it is. Okay. No, the first one.
All right, so then we get into our geologic time, which is how scientists have broken up major events that have occurred in Earth. You have your eons, which is your greatest time period. From there, you have your periods, then you have your eras and your periods and your epochs. There are 4 main eras, and the first one is the Precambrian. And this is from the formation of Earth about 4.6 billion years ago. And this is about 90% of Earth's life history. So they just basically look at fossil evidence and changes in the rock layers to develop the history and the time scale of Earth. We know that Earth's first continents, you have your ocean crust and your continental crust, and they differ due to density and type. And we know that continental crust is silica rich, while your oceanic is basaltic, because it comes from, remember the oceanic crust comes from magma, so it is basaltic. And then your less dense rock rises, and it resists being recycled in the rock cycle. So, also during the Precambrian, you have the supercontinent cycle. We learned about Pangaea when we went over plate tectonics. But before that, there was another supercontinent called Rhodina. And this one did end up splitting apart. And Gondwana was comprised of South America, Africa, India, Australia, and Antarctica. And the formation and movement of these continents is known as the supercontinent cycle. You also had your mountain formation during this time and sea level rising. From there, you move into the Paleozoic era, which is just basically, Paleozoic means ancient life. During this time, your invertebrates dominated, and it was mostly your trilobites. And this is also when Pangaea formed. Again, eras are marked by, the end of the eras are marked by a mass extinction event. So the Paleozoic.
But you said Rhodina was the first supercontinent. What, it broke apart and then came back together to form Pangaea?
Yes. Yeah. So it's just, the supercontinent cycle is just the breaking apart and moving of the continents and just rearranging. And then we know that Pangaea ended up breaking apart to move it to where they are now. And they say, eventually there'll be another supercontinent called Pangaea Ultima. About like 250 million years.
That's gonna happen? Wait, it's gonna keep coming together and then breaking apart?
Mm-hmm.
Oh, it's a cycle.
Yep. So, Paleozoic era, like I said, was the basically the age of the trilobites, and then at the end of eras are marked by mass extinction events. So, to end the Paleozoic era, you had the Permian extinction, which killed off about 90% of all marine animals and about 70% land animals. This was all due to 3 things: lowering of sea level, increased volcanic activity, and climate changes. Oh, the frill shark? Yeah, this is a frill shark.
Wait, they discovered it in 2007. How much?
They found this one in 2007, and they call it a living fossil, so they're saying that it existed back during the Paleozoic era. It's a shark. It's a frill shark. So then we move on to the Mesozoic era. This era is the age of the dinosaurs. So at the beginning of this era, you have Pangaea was still together, but in the middle of this era, Pangaea broke apart. Reptiles were most dominant for 2 reasons. One reason being that their skin could maintain body fluids. The other reason was because their embryos could live in shells, so they could survive those dry climates. Again, dinosaurs were active. And then again, another mass extinction event occurred about 65 million years ago, which killed off the dinosaurs and most other life due to the meteorite collision. So then we move on to the Cenozoic era. This is the era that we are currently in now. Mammals evolved during this time. Humans came into existence about 3.5 billion years ago. And we are still, like I said, currently in this era. And you had your large mammal extinction. 3.5 billion years ago. Sorry, I said billion. 3.5 million years ago. So you also have Earth's first life, which was just basically like a primordial ooze or soup. And it was just the simplest life form. And they say that the oldest fossils are buried the deepest. And they were simple single-celled creatures. So prokaryote, which is a simple single-cell bacteria that was thought to be the earliest life form. And that is what your eukaryotes formed from, which are your multicellular creatures. Alright, so today, you guys have a Google Slides activity that you're going to do. I'm going to give you a copy of this. Don't write on this or take it with you because I just made class copies. But basically this is your geologic time scale. It has all the information that you will need to be able to complete the questions on the Google Slides activity. I will be coming around and helping if you need help. However, this does count as a test grade. So it is graded for accuracy and correctness. So you can work in groups, you can talk to each other, you can help each other. But again, like I said, it does count as a test grade. Instead of doing a test on this unit, we're just going to do this activity and it's going to count as your test grade. So again, all the information that you should need is on this paper that I'm going to hand out. And I printed it out so you guys didn't have to keep going back to the slide. So like I said, I will come around to help you guys if you need it.